Hello my dear friends. Today we are meeting in the third lecture of Laplace transform. In this lecture we would be studying some fundamental properties of this transform function, Laplace transform. What are the properties of? There are 6-7 properties by virtue of which we would be finding out in future the Laplace transform of some more varieties of functions. So, let us start with the first property. First property is also called as first shift property. First shift property. So what does it says? If the Laplace transform of function f of t is say f of s, then Laplace transform of e raised to power at into f of t will be equal to capital of S minus e. Or Laplace transform of e raised to power minus at into f of t will be equal to f of s plus a. What does it mean? It does mean if we know the Laplace transform of any function f of t and known value of that function Laplace transform is f of s, then we can compute directly by this property the Laplace transform of e raised to power at into f of t or e raised to power minus at into f of t from f of s. In f of s, if we replace s by s minus a, that would be the Laplace transform of e raised to power at f of t. If s is replaced by s plus a, that would obviously equal to Laplace transform of e raised to power minus at into f of t. How? See here. I will justify this. Laplace transform of e raised to power at into f of t. What does it mean? It is equal to integral 0 to infinity e raised to power minus st into this function e raised to power at into f of t dt. That is further equal to integral 0 to infinity e raised to power minus times s minus a times t into f of t dt. And what is this? It is f of s minus a. Why? Because how we define f of s? Laplace transform of f of t, integral 0 to infinity e raised to power minus st f of t dt. Integral 0 to infinity e raised to power minus st f of t dt is f of s. Instead of s, here we do have s minus a. So it can be denoted by capital F of s minus e. Similarly, we can prove this. Laplace transform of e raised to power minus at f of t is f of s plus a in view of this the Laplace transform of, say, t square into e raised to power minus 2t. Here, e raised to power minus 2t is multiplier. So function is f of t square, other than exponential function, multiplier function. What is the Laplace transform of t square? F of t is t square. So f of s, Laplace transform of t square, it is 2 factorial upon s cube. So by the first shifting property, Laplace transform of e raised to power minus 2t into t square is equal to f of s plus 2. In this f of s should be replaced by s plus 2. So it would be equal to 2 upon s plus 2 whole cube. So 2 upon s cube is Laplace transform of t square, whereas 2 upon s plus 2 whole cube is the Laplace transform of t square into e raised to power minus 2t. So any function, if it is multiplied by e raised to power either minus 80 or e raised to power plus 80, we would be directly finding out the product of Laplace transform f of t into e raised to power plus minus 80 by f of s plus a and f of s minus a by this property. This is also called as the first shift property. So P2. P2 is called as second shift property. So what does it state? It states that if Laplace transform of f of t is f of s and let capital F of t be a function defined by, say, it is 0 when t lies between 0 to a and it is equal to, say, small f of t minus a. If t is greater than a, then Laplace transform of this newly defined function capital F of t is equal to e raised to power minus as into f of s. This is called as the second shift property. We shall prove this property. So, what is the Laplace transform of capital F of t? Laplace transform of capital F of t by fundamental definition is 0 to infinity integral e raised to power minus st into capital F of t. Now capital F of t is defined from 0 to a and a to infinity. From 0 to a, its value is 0. And from a onwards to infinity, its value is small f of t minus a. So this is equal to integral 0 to a e raised to power minus st into f of t plus integral a to infinity e raised to power minus st into f of t. In this interval 0 to a, this capital F of t function takes the value 0 in 0 to a. So first integral is 0 plus second integral is integral a to infinity e raised to power minus st, and in this interval a to infinity from a and onwards the function is f of t minus a. Value of capital F of t is this. Now we would be evaluating this integral. If we put this t minus a is equal to say x, t minus a is equal to x, therefore dt is equal to dx. Now when t is equal to a, x is equal to 0. When t is infinity, x is infinity, so this limits reduces to 0 to infinity. E raised to power minus s into, what is t? T is x plus a into f of x, and dt is dx. E raised to power minus as minus sx. So it is, this is, we are transforming t to x. So this s is independent of x. So this is equal to e raised to power minus as into integral 0 to infinity e raised to power minus s x f of x dx. So that is nothing but your e raised to power minus as into f of s, because e raised to power minus st into f of t dt is integral 0 to infinity is Laplace transform of f of t. Here the dummy variable t is replaced by x, so it does not change the value of integral. It would be f of s. So that proves your second property, which is also called as the second shift property. Third property, P3, multiplication by T property. This property states that if the Laplace transform of f of t is f of s, then the Laplace transform of t to the power n into f of t is equal to minus 1 to the power n into nth derivative of nth derivative with respect to s of f of s. Most important property, most widely used property. If function f of t is multiplied by t, powers is 1, 2, 3, 4 and so on, t square, t cube, t and so on, then the Laplace transform of such product is equal to this, minus 1 to the power n, nth derivative with respect to s of f of s. If n is equal to 1, Laplace transform of t into f of t is minus 1 dds of f of s. If n is equal to 2, Laplace transform of t square into f of t is minus 1 square, means it is positive, into d second derivative with respect to s of f of s, f double prime of s, and so on. So for n equal to 1, I will be proving this. So Laplace transform of t into f of t. What is the definition? Integral 0 to infinity e raised to power minus st into t into f of t dt. By definition. But we would now be proving that this Laplace transform of t f of t is nothing but minus 1 into d by ds of f of s. Minus times dds of f of s. Negative of f prime of s. So, what is f of s? We know that. What we know? F of s is equal to integral 0 to infinity e raised to power minus st into f of t dt. Now, this is definite integral. Limits are constant 0 to infinity. Integral is with respect to t. So, variable of integration is t. But s is parameter. So, I would be differentiating this equation with respect to s. Differentiating with respect to s. That means f prime of s is equal to d by ds of integral 0 to infinity e raised to power minus st into f of t dt. Now, here I would be using and introducing the Dewey's rule. This d by ds becomes partial differentiation under the integral sign. This is equal to integral 0 to infinity dou by dou s of e raised to power minus st into f of t into dt. What is partial derivative of e raised to power minus st with respect to s? Integral 0 to infinity. Partial derivative of e raised to power minus st with respect to s is e raised to power minus st into minus t. Minus t into f of t into dt. So f prime of s is equal to negative of integral 0 to infinity e raised to power minus st into t into f of t dt, which can be considered as minus times. This is the Laplace transform of t into f of t. So, f prime of s is equal to negative of Laplace transform of t into f of s, multiplying this equation by minus 1. Therefore, Laplace transform of t into f of t is equal to negative of f prime of s, that can be rewritten as minus 1 raised to power 1 into d by ds of f of s. Writing in a more fashioned manner, handsome manner, f prime of s as d by ds of f of s. Now, we once again differentiate this f prime of s with respect to s. Again, it would be f double prime of s. Again, we would be introducing the Dewey's rule. Again, one negative factor will be introduced. So, it would be t square, Laplace transform of t square plus f of t and so on. So, we can show further multiplying properties. So, this is called as multiplication by t T property. To illustrate this property, Laplace transform of e raised to power at is, or e raised to power 2t is 1 upon s minus 2. Therefore, Laplace transform of t into e raised to power 2t by this property is equal to minus 1 into d by ds of f of s. This is f of s. So minus 1 into d by ds of 1 upon s minus 2. So that is equal to minus 1 into, and derivative of this is minus 1 upon s minus 2 whole square. So that is equal to 1 upon s minus 2 whole square. Laplace transform of e raised to power 2t is 1 upon s minus 2. Whereas e raised to power 2t. But Laplace transform of t times e raised to power 2t can be obtained by multiplying by minus 1 and differentiating with respect to s using this property. So, one more important property, which is called as division by t property. It states that if Laplace transform of f of t is f of s, then Laplace transform of f of t by t is obtained by this formula, integral s to infinity f of s ds. Laplace transform of f of t by t, when f of t is divided by t, then its Laplace transform is obtained by integrating f of s between the limits s to infinity. So, if it is divided further, f of t upon t square, again integrating, 2 times integrating from s to infinity of f of s, t cube and so on. We can repeatedly use this property of division by s. Now we shall illustrate this property, proof of this property. We shall prove that right hand side is equal to left hand side. What is this right hand side? Integral s to infinity f of s ds. That is our right hand side. Right hand side is this. Integral s to infinity. What is f of s? Integral 0 to infinity e raised to power minus st into f of t into dt into this ds. Value of this f of s. The limits of t, they are from 0 to infinity. And limit of s, they are from s to infinity. I will interchange these limits. This is further equal to integral 0 to limits 0 to infinity f of t into integral s to infinity e raised to power minus st ds dt. That is further equal to integral 0 to infinity. Now what is this? Integral of e raised to power minus st with respect to s, it is e raised to power minus st upon with respect to s. So e raised to power minus st divided by the derivative of minus st with respect to s. So that is equal to minus t. Limits are from s to infinity dt. And this f of t. So that is further equal to integral 0 to infinity. Now I would be computing this f of t by t, f of t by say minus t into. Now e raised to power minus infinity is 0. Minus e raised to power minus st, s is equal to s is same, e raised to power minus st dt. Minus minus will become plus, so it is equal to integral 0 to infinity e raised to power minus st into f of t by t. And again by the fundamental definition, this is nothing but the Laplace transform of f of t by t. From the definition. Now we will be discussing the last property, which is called as the change of scale property. P5. If Laplace transform of f of t is f of s, then Laplace transform of f of at can be directly written as 1 upon a into f of s by a. If this in function f of t is scaled as at, a times t. If we know the Laplace transform of f of t, then the Laplace transform of f of at can be equal to 1 by a. Any Laplace transform of f of s, s is replaced by s by a. See here now. What is Laplace transform of at? Very simple. By definition, integral 0 to infinity e raised to power minus at into f of at dt. Put this at is equal to say x. So a dt is dx, or dt is equal to dx by a. When t is 0, x is 0. When t is infinity, x is infinity. Therefore, Laplace transform of f of at is equal to Laplace transform of f of x, because at is equal to x. That is equal to integral 0 to infinity. When as long as t varies from 0 to infinity, x also varies from 0 to infinity. E raised to power minus s t. What is t? It is equal to x by a into f of x and dt is dx by a. So that is equal to 1 by a times integral 0 to infinity e raised to power minus s by a times x into f of x into dx. That is nothing but 1 by a times, and this integral can be written as f of s by a. Why it is written as f of s by a? Because integral 0 to infinity e raised to power minus st f of t dt is f of s. In view of this, integral 0 to infinity minus s minus x times s by a f of x dx, that would be f of s by a. Instead of s, we do have here s by a. This x and t, they are dummy variables, so this integral can be written as f of s by a. As we write integral e raised to power minus st f of t dt is f of s. So that illustrates or proves this fifth and last property. Some more two properties are left that we shall see in the next lecture. By using these properties, we will be solving some more examples. So thank you very much. Thank you all of you.